Well, we are going to get back started working on this once again. Thank you, Lucas. So what are we doing first? Let me just double check what Adam's up to. Make sure he's not complaining about me. So he's just working on more animations. Alright. He'll be working on that for a while then. Alright, so what do we need? For our test level. Well, we had some basic test segments here, but they're not super great for what we're doing. So where's that guy coming from? Like, Fat Sack's coming from somewhere, isn't he? Like, why are we having Fat Sack coming from places? So let's see, where is this Phantom Fat Sack coming from? Something that has to do with maybe the player? Like, we've got initialization stuff. Oh, okay, so here we go. Here's where we're actually making our character creation stuff. This is a Fat Sack proxy with the Wander state set to begin with. Alright, well, the mystery of the Phantom Fat Sack has already been solved. We solved it right there. It was us all along. This camera seems super zoomed in compared to what it should be. Alright, but are these good for our platform? Yeah. So what were our things? Players getting stuck inside of each other, hitting a small edge. So only fix the hitting a small edge first. Now we're also going to want to tune extreme angles for bitey. I don't know what you're talking about, Lucas. Alright, so no, this camera angle is more of what we have in the game. So I don't really know what your point is. Alright, so we have lighting, we are in shadow in here, that's good. So this allows us to jump. What we should be looking at is this guy first. So what's happening is there's a lot of things that have to do with making something look 2D. Camera angle is one tool, but I duplicated his camera. It has a lot more to do with, I think, the way that the terrain is laid out. And the terrain being 2D or not. So this is going to be inside of the movement. So this has to do with when we hit an edge and we travel up it, and we go really, really far up and there's no way to snap down. So what is the question here? The question is, we're going to go into So we're moving along, and then we have a big ramp sort of thing. And our character is moving so fast that when they jump up this ramp that they leave the floor. And so basically, you know, he has this tiny little ramp and just boom, he's off in the air. So things that we could do, we could do sub-movement steps that are shorter based on your speed. So we could always try to move you not only in regular intervals, but also regular distances. So like if you move to here, we would try to snap you to the floor here. So you're moving super quick, and you'd actually move in a lot of different segments. Same thing if we're going like this, where we run off and we run off the edge too fast where we can't actually snap to the ground. So we could sweep by movement segments, or we could have an increasing snap distance based on the distance that you move. So there'd be some issues, like if we did it in increments, your character, you know, we would move you more often, and you know, you'd basically move to here, snap down, and then you'd move again and snap down, and move again and snap down, and all that, and so your character would end up moving like sort of that. In computer space, kind of, you know. But if we did like this moving snap here, we'd actually move you to here, so your actual character movement would move here, and then it would actually move down. And the issues with that is if maybe there was some object here that you should have collided with that you would not collide with, that you would just slam to the ground, and you'd be able to like teleport through the object just because by grace of your movement you moved over it. So it seems like the most correct way would be to actually subdivide our movement based in steps. So we're going to need a distance-based movement step. So the question is now, when should we use this distance-based movement step? So if we move the whole object and we try to snap you to the ground, like if there was somehow a platform right here, you might move and then snap to the ground right here. The question would be, is that acceptable as a movement strategy? And I think probably. So it seems like the best course of action is that we should do this distance-based movement. If you sweep and you don't collide with anything. So what would that look like? Because it's inside this movement on ground. This will move us right here, like we didn't actually do anything, and we do like update snap to floor. So let's check this out. So what we'd want to do is like re-simulate based on our speed. I mean, I guess the most correct thing to do would be to always basically re-simulate based on speed. But I'd rather not have everything like go into super ridiculous movement checks just because we're moving quickly. It should definitely be like if update snap to floor. I'm trying to think about how to organize this code because we're basically doing a special case of re-simulating something, which is not what this is set up to do. I mean, the other thing here is if we just scaled our value here, basically this vector, this launch vector is always going to be, this is going to be dt multiplied by our velocity. So we just add this vector here as like a downward. So what is that? Is that the sine or something, like the cosine of the angle multiplied by the magnitude of the velocity or something like that? Or is this the cosine and this is the sine, like negative sine? Multiplied by that. What's the sine of 20 degrees? Sine of 20 degrees is that? What's the cosine of 20 degrees? Cosine is 0.93, so it's going to be the sine of the launch angle multiplied by the angle. So the floor stick distance is actually going to be the extra stick is going to be the movement direction vector dot size, and we need to know the angle. I guess we'll have it. Yeah, we need to just have it always do this. The launch angle is going to be the angle from the vector. Do we have anything like that already? Yeah, we've got get angle from vector. I guess I already know the component of the y movement in the direction. It's just going to be the velocity in the z-axis multiplied by the. So we just need not the. We don't even need the z, do we? We need the movement distance multiplied by the movement direction vector dot z. So we'll do fmath absolute value of this. So let's see if that does what we want. Basically, we're going to take our Z movement that we did, and we're going to add that to our stick distance. So we should stick to the ground. And yeah, our movement direction is not going to be componentized. I mean, it's not going to be like an iterative movement. It'll just be like you move up, you actually launch into the air, and then we're going to slam you to the ground even harder based on how fast you're going. So if you were going at infinite speed or whatever off a ramp, you may actually stick to the ground in places that you shouldn't theoretically be able to do that. Because if there was like a little obstacle right here you're supposed to run into, you would just like fly right over it. But we can always, have the speed of light and have it be you can't go any faster than this, and that should solve our problems. Speed of light, the greatest hack in the universe. That's how you know God was a programmer, because he's like, fuck it, nothing can go faster than this. And on the 7th day, he banked out all the code and then went the hell to sleep. Or the 6th day he did that. Well, you see, that's where you just like wave your hands in the demo, and you're like, that's supposed to happen. It's like, nobody really cares. Did this level not save? We're just in the wrong level. That's what's going on. Yeah, exactly. Well, he's not flying into the air. In terms of he's not like jumping up anymore in a massive, ridiculous display of insanity. But it's definitely not as far as it should be. So yeah, we're getting back into this movement code, which we have not touched in a very long time. It's pretty cool. We're getting back and doing kind of an iteration on kind of how it works. Because I know this is one of the things that has been kind of annoying. Because kind of how you do work in game development is you iterate on things. You kind of finish everything in one form, and then you come back and you make it better later. And it was pretty funny because as soon as I was like, okay, movement's done for now, and Adam boots it up and like he's moving around and his character's glitching like hell, and he's like, what the fuck? This isn't done. I'd be like, no, this is version 1. Like you built a level that wasn't specifically tuned to the movement, so it's gonna look kind of messed up. Grumble, grumble, grumble. Alright, so the floor stick distance was 20 with an extra 0.000026. Doesn't make much sense to me. Why? I guess if our Z movement wasn't much. Yeah, but I want it to work now. Yeah. That's how we characterize all the... As engineers, we look at all the designers and artists. They're just a bunch of whiny babies. That's what we all do in our engineering meetings. Is we just do like our best artist impression, and it's just like, yeah, why did it work? Yeah, Perforce is so annoying. And they do the same thing in their meetings. So it's kind of this mutual hatred. And their impression of engineers is like, everything is impossible. Hey, you didn't ask for that beforehand. Why can't they just follow a 12-step process that we laid out? And really, the truth is, everybody's a whiny baby. And everybody's correct in their impressions of each other. Our Z movement was very small, and our move distance was 15. So we definitely want, like, the move distance is... We should be, like, adding the move distance, and we should also be adding the Z times the move distance, I think. Something like that. Like, it should be the movement direction Z times the movement distance. Then we just add the movement distance to this thing. Complain. Should be the New World Religion. It's just a bunch of people that, like, on Sunday get together in the morning, and then just, like, the priest or whatever just gets up there and bitches about stuff. And people are just like, yeah, that sucks. And they all go home, and they feel self-righteous about having bitched about stuff for an hour. But don't forget, they have to, like, eat cookies and stuff like that, because that's a big part of church. You can tell I'm a very religious person. Alright, so we are... I mean, the biggest thing here is calculate floor stick should also take into account the movement distance. And the other argument would be, should we just base it off the movement distance? And I think probably, like, because we're getting screwed on some other things, I think we want to take the movement distance into account for the floor stick. And then we'll basically just add the movement distance in there, and maybe that'll be enough, you know? Alright, so this is just going to be a 0 movement distance. This is going to be that movement distance. This is going to be update obstructed floor path. Alright, so movement distance is going to be here. Attempt to traverse seam. Alright, so we already stuck ourselves to the floor here. So we actually moved ourselves yet? It's like, no, we haven't actually moved ourselves. So attempt to traverse seam. Are we actually calling this recursively? No, we're not. So let's see if we can actually do like movement distance in here. So I think that'll do that for the traversing the seam. So updating mantle. Let's take a look where we've got this. Oh, this is a tricky one, isn't it? The floor stick distance based on mantling. I mean, mantling already takes all this stuff into account. Does it? Pretty sure it does. So maybe we don't actually have to do anything for this. Alright, so this is movement in the air. We're not going to have any extra snapping because we're in the air. And this is in the air. Alright, let's see if this actually fixes our issues with flying off. Is this a bug right here where we could potentially be flying? Might be. Well, maybe it's not an issue. Like, these can theoretically have us not be on the floor anymore. But they shouldn't change anything, so why don't we just double check. See if these conditions ever actually happen for snapping to the floor when mantling over objects or some other type of movement. And we have line numbers for our log, so I'll be able to tell which exact line is telling us when we are flying, when we should be sticking to the ground. So 627 is saying bad things? No, it wasn't actually saying bad things. Alright, we're going to go ahead and change that default level so that we're starting in our movement test level. That'll make things a lot easier for us. So I don't have to select that level every single time. Alright, let's see if we're actually having any issues anymore. So we were jumping up over that thing earlier. So it looks like 517 is causing us to fly off. 517 is here. So the issue is, like, the slope is so extreme that we run down it. That our character basically runs into this seam here, and then they're moving like this out here, and then moving down is just huge because, you know, it would have been a massive move. So I mean, we could attempt to, you know, substep our stuff here so we wouldn't have such a massive drop. The other thing we could do is we could say, like, well, it's an interesting question, because what we could do is we could move, like, our character just a certain set distance to start with, or no, we need to basically when we're moving our character, we could either have them snap to the ground, which would actually at this angle snap them, you know, down here. And what's the distance here? The distance, like if we're running this direction, you know, this vector here is actually going to be bigger than this vector, I guess, because this will be 90. Thank you for following, Rinku. We're working on this movement right now. We're trying to get the edge cases with snapping to the floor with our character running, and a lot of this has to do with, like, in reality, if you're running down, you know, a giant slope, and then you, like, your character collided with a tiny little ramp, in reality you're just gonna, like, you're gonna trip and then just, like, eat shit all the way down the slope with your face, and by the time you get to the bottom, you're gonna look as ugly as Bitey does. But, you know, also in reality, if you weren't gonna just trip, you would just step over this. You know, you wouldn't collide with it because you'd see it coming, and you would just put your foot over the top of it and continue sliding, or running or whatever. But because this is a game, you know, we're not simulating their feet or something. We need to actually kind of, you know, we have to deal with these little microscopic hiccups properly. So one solution would be we could just put the floor stick distance at some ridiculous sort of value. But that's not really what we want, right? Because, like, if you're running along a straight path, we don't want your character to just, hit the ground immediately. Like, if we're running super quick, you know, we don't want the character to just just snap to the ground. Like if you're running really fast and all of a sudden there's no ground under you. Really, I think what we're trying to do, like maybe we got our algorithm wrong there with our stick distance based on our velocity, because this would mean we could, if you're going super fast, you could like snap to the bottom of a cliff just by running super quick off of it, right? Like that's not a problem. And it's not a thing necessarily with momentum. Like this has to do with our geometry. Like what we theoretically would want is we'd want right here when we are no longer touching the ground. We'd want to cast down and we'd want to see, oh, there's nothing below us at this exact spot. And then then we'd want to, snap lower based on that. So the Z component should definitely be our snap. Like I don't want to build in momentum for a snap distance. I'd rather solve it on like a per situation basis, not a momentum basis, because I don't want it to be like a history based thing, because if then like you immediately started going from like 0 speed to 1 speed, like you got knocked up by an explosion, just boom. Like we should still follow the correct rules and everything else. We don't want to add in some sort of history to our movement, because that also makes it incredibly difficult to debug, right? Because now I can't just walk through the math on something. Now I have to walk through the math of like 20 frames of random bullshit. So one thing here is basically like, we could just fix the geometry and just be like, if you've got something like this, like go to hell, you cannot have that. Just fix the geo. Well, okay, that's fine. We could have like our steps here, so every single time that we're moving, we could, in regular intervals, take like a little vector and cast it down and see if we encounter something. And if we don't, then we can like try to solve that. It's a lot of raycasts. But it's based on distance, so it's not actually too awful. Alright, so I definitely think we need a movement direction vector. We need a Z component to our movement. Ah, that really doesn't... Yeah, it has to be based on Z. So it's kind of like that. Oh yeah, so we need to make sure this is the absolute value of the moment distance, because if it's negative, then it's going to be negative. So if your Z is greater in the negative direction for your movement, yeah, okay.